Chapter 4.6 covers isosceles and equilateral triangles. The isosceles triangle theorem states that if two sides of a triangle are congruent, then the angles opposite are congruent. So looking at this picture, what this theorem tells us that if the sides AC and BC are congruent, then angle A has to be congruent to angle B. The converse, and we studied the converse in chapter 2, means you flip the theorem. So the converse would state that if the two angles of a triangle are congruent, then the sides opposite are congruent. So in this picture, we're given that if angle D is congruent to angle F, then the sides opposite, DE and EF, have to be congruent. An equilateral triangle is a triangle that has all three sides congruent. And the theorem that we have states that if a triangle is equilateral, or in other words, it states that a triangle is equilateral if and only if it is equiangular. So an if and only if statement means it doesn't matter which way it goes. That if a triangle is equiangular, then it's equilateral. If a triangle is equilateral, then it's equiangular. And I think we've already discussed that the angles of an equilateral triangle are always 60 degrees because you divided 180 by 3. So for the first problem in this picture, we want to find the measure of angle R. So we want to find this measure here. Since we know that it is isosceles, because PQ is congruent to QR, we know it's isosceles. So that gives us that angle P has to be congruent to angle R. Well, since the first one's 60 degrees, we would have 120 degrees left. That divided by 2 would make both of these 60 degrees. Well, if they're all 60 degrees, then it has to be an equilateral triangle with all three sides congruent. So the measure of PR would also have to be 5 centimeters. In the next problem, we're given that DF is congruent to EF. So we would have 6y plus 3 equals 8y minus 5. So 3 would equal 2y minus 5. 8 would equal 2y, and y would equal 4. But if this angle E right here is equal to 4x minus 8, well, if angle E equals 4x minus 8, and angle F equals 4x minus 8, yet we know it's isosceles, so we know that D has to be congruent to E, then D also has to be 4x minus 8. So to solve this for x, we would do 3 times 4x minus 8, because we have 3 angles that are 4x minus 8, equals 180. So solving that algebraically, we have 12x minus 24 equals 180. 12x equals 204, and x equals 17. In the next problem, we're told that it is equilateral. So we know that all 3 angles are congruent. So 3 times 3x equals 180. 9x equals 180. So x would equal 20. We also know that the sides are congruent, so 2y minus 6 equals 8. We don't have to consider all 3 sides, we just know that this side is equal to this side. So 2y equals 14, and y equals 7. In the next one, which statement correctly names 2 congruent angles? So what I'm looking at in this picture is that JM is congruent to JK. So I'm looking at the big triangle. So that tells me that this angle here has to be congruent to this angle here by the isosceles triangle theorem. So this would be JML or JMK. So the first one that has JMK here is this one. Is it JKM? So JMK and JKM, that would work. In the next problem, we're asked which 2 statements correctly identifies 2 congruent segments. So I'm looking at the fact here that this angle here, PML, is congruent to PKL, which tells me that PM has to be congruent to PK. So that would be the last one. So I want you to complete the coursework. On the very last problem where it says write a 2-column proof, I don't necessarily want you to write a proof, but write your reasons why you know. How would you go about proving it? So I don't care what order you have written it in. I don't care how you do it, but at least write your reasons why you know. So it's going back to what you know from parallel lines and maybe alternate interior angles, consecutive angles or corresponding angles, but it brings in your previous knowledge of parallel lines. So I'm trying not to give away the answer to that and have you think about it. So this concludes the lesson for 4-6.